We'll now discuss the graph operations. Going to start with the complement of a simple graph. So the original graph has a set of vertices and edges, G equals V comma E, and its complement or G bar actually is equal to the same vertices, comma, and the opposite of the edges. So this means that our vertices or our nodes or points are the same. We will not be changing our vertices. So the first step to draw the complement of a simple graph is to label all the points. So perhaps I can put it here. This is our G. We have V1, V2, V3, V4, and V5. Okay, so the first step is to label all the points. This is V3. This is our V2. This one is V1. Here is our V4. Let's move this one a little bit. And we have our V5 here. Okay, so these are the original points. We are not going to change our points. What we're going to change is only the set of edges, because our E becomes E bar. So let's look at V1. So you can see V1 is adjacent to V2 and V4. The opposite of this is V3 and V5, because there is no direct connection from V1 to V3 and from V1 to V5. So let's draw that. So the line from V1 to V2 is deleted now. We don't have this line. And our line from V1 to V4 is also deleted. Now let's look at our V2. As you can see here, V2 is connected to V1 and V3. So the opposite is V4 and V5. As well as V5. Now our V3 is connected to 2 and 4. So the opposite is 1 and 5. It's connected to 1 already. So we have to connect V3 to V5 only. Our V4 is connected to 3, 5, and 1. So it should be connected to V2. It's already connected. And V5 is connected only to 4. So the opposite is 3, 2, 1. But it's connected already. 3, 2, and 1. So this is the answer. This is the opposite of this graph. Now there is additional question here. You're asked to find the complement of G and identify the number of edges using n choose 2 minus m. This one is always 2. Why? Because actually in a simple graph, an edge always contains 2 points. Like this, for example, this edge, it uses 2 points, V2 and V1. This edge also uses 2 points, V2 and V3. So for every edge in any simple graph, it consists of 2 points. So let's try to find the number of edges of our complement. Okay, so this is the formula, number of edges of our G bar equals n choose 2 minus m. Let's fix this to be very clear. Okay. These two lines here, left and right, means number of, this is edges of G bar, G complement. So our n is number of points or number of nodes, and m is number of edges of the original graph. So please take note that this is using the original graph. This is the original graph, our G. So there our n is 5. 1, 2, 3, 4, 5. And our m is also 5. We have 5 edges. We have E1, E2, E3, E4, and E5. Okay, so now let's replace our variables. So this would be 5, choose 2, minus 5. Okay. So how to get this one in the calculator? 5, press NCR 2, minus 5. We're going to get 5 as the answer. Now, manually, you can also do this using this formula. Because n choose 2 here is actually, or basically the number of combinations. So our n is 5. R here is our x, which is always equal to 2. Okay, so using the formula, actually, this will become 5 factorial over 2 factorial times the quantity of 5 minus 2 factorial. So 5 factorial is 5 times 4 until 1 over 2 factorial is 2 times 1. And this one is 5 minus 2 factorial, that is 3 factorial, or 3 times 2 times 1. So this is deleted. So 3, 2, 1 cancelled. The remaining is 20 over 2. That is 5 times 4 over 2 times 1 equals 10. So that is why the answer here is 5, because 5 NCR2 actually is 10. 10 minus 5 is equal to 5. Okay, so the answer is 5. We're going to look at the G bar. We have E1, E2, E3, E4, E5. So we have 5 edges in our complement, which is correct. Okay, so let's have one more example for you to understand this one better. Okay, this is our graph. The name is B. So what we're going to do here actually is to draw the complement of this graph. So I'm going to put the answer here. It's going to be B bar or B complement. This is our B complement, or the opposite of B. So the first step is to label all the points. We have our V1 here, our V2 and V3. This is our V6 here, and V5, and this is our V4. Okay, so this is the first step always, to draw the complement of a simple graph. Okay, of course, this graph is simple. Why? Because we don't have loops, we don't have multiple edges. Okay, so let's look at our V1. V1 is adjacent to 2 and 6. So the opposite is 3, 4, and 5. Because we don't have a line from 1 to 3, 1 to 4, and 1 to 5. So we can do it like this. Okay, so as you can see, from V1 to V2 is deleted, 1 to 6 is deleted. Let's look at our 2. 2 is adjacent to 3, 1, and 5. The opposite is 4 and 6, because we don't have a line from 2 to 4 and 2 to 6. So this is 2 to 4 and 2 to 6. Our 3 is connected or adjacent to 2 and 4. The opposite is 5, 1, 6. Okay, it's connected to 1 already. So we have to draw 3 to 5 and 3 to 6. Right? You can make a straight line or whatever it is for this. Or even you can go out if you want to. Okay, so the 4th here is connected to 3 and 5. The opposite is 2, 1, 6. It's connected to 2 and 1 already. So we just have to connect 4 to 6. 5 is connected to 2, 4, and 6. So the opposite is 1 and 3. It's connected already. 6 is adjacent to 5 and 1. The opposite is 2, 3, 4. But it is connected already, 2, 3, and 4. So this is our answer. This is the opposite or the complement of B. Now, let's find the number of edges of our B complement using the formula. So, number of edges of B bar equals n choose 2 minus m. Okay, so we have n 1, 2, 3, 4, 5, 6, and our m we can label 1, 2, 3, 4, 5, 6, 7. So you have 7 edges there. So this will be 6 choose 2 minus 7. In the calculator, it's going to be 6 NCR2 minus 7. So basically, this is actually 15 minus 7 is equal to 8. Or you can use the formula, of course. It's going to give you 15. That is 6 factorial over 2 factorial. And we have 6 minus 2 factorial. it will be 15. So if we're going to check, here we have 1, 2, 3, 4, 5, okay, 6, 7, 8. So we have 8 edges in our B complement, which is correct. Right, so that is how to identify the complement of a simple graph, and also to count the number of edges of our complement. Okay, so the answer is this. There are 8 edges. Now the complement of a complete graph is a null graph. Okay, when I say complete, all the points are connected to each other. Like V1 is connected to 2, 3, and 4. V2 is connected to 1, 3, and 4. It's connected to all. V3 is connected to the rest, and V4 is connected to the rest of the nodes or the points. So our complement G bar will be null graph. Of course, because the original here, you can see that all the points are connected to each other. The opposite of that is all the points are isolated. They are not connected to each other. Okay, so let's proceed now to the difference of the graphs. This is our G, and this is our G prime. Okay, and we're going to subtract G and G prime. So G minus G prime. When we actually subtract graphs, what we're going to do is to delete the edges only. We're just going to delete the edges. The first step is to draw all the points of the first graph. This is the first, because you have G minus G prime. This is the second. So first and second. So the first step is to label all the points. We have 5 points actually. And we're going to delete all of this, this, and this. Okay, so this one is not deleted. Okay, this one is not deleted. This line is deleted because we have this line. This line as well is deleted. And this line is deleted already because we don't have a line here. Okay, so we don't need to delete that one again because it's deleted already. So this is the answer. Right? Only 2 edges remaining because actually 4 edges are to be deleted. 1 is deleted already. So we deleted this line, and this line. So this is our answer. Now let's have this one, P minus K. This is our P and this is our K. So the first is to draw all the points. We have again 5 points. 1, 2, 3, 4, 5. Okay. Now we are going to delete 3 edges. This, and this. Okay, so 3 edges we're going to delete. So this one is not deleted. This one as well. It's not deleted. Okay. This line is deleted. But this line is not deleted. Okay. This line is deleted. This line is not deleted. Okay. So we have 1, 2, 3, 4, 5, 6, 7. 3 are deleted. So the remaining only 4. 1, 2, 3, 4. This line is not there anymore. We don't have a line here, and this line, and this line. Okay, so this is our answer. This is P minus K. Only the edges are deleted. Now let's have the union, intersection, and ring sum. So this symbol is union. This is intersection. And this is ring sum. Okay, so I'm going to explain these concepts by giving you some examples. When we talk about union, intersection, and exclusive or ring sum, we also call this as exclusive OR. We are talking about simple graphs actually. Okay, same with the complement. Now to get the union, we have to combine both of these graphs. So what we're going to do is to draw first the first graph. Okay, so let's draw the first graph. 1, 2, 3, and 4. We have E1 here. We have E3. This is E4 and E5. Okay. Now let's combine this with G2 because G1 union G2. We don't need to draw this again, 1, 2, and E1 because it's common. What we're going to draw is E2 reconnected to 5. So that is E2. And 6 is here. It's not connected to any points. Okay, so this is the combination of G1 and G2. We added E2 actually, because we have E2 here. E1, we don't need to draw it again because it's already there. It's common elements. Okay, now the second one is G1 intersection G2. Intersection means common elements. So those points and edges that you can see on both graphs. So we can see 1, okay, and 2, as well as E1 in both graphs. So the answer actually is this E1, where 1 is connected to 2. So that's the only intersection we have. Vertex 1, vertex 2, E1. The last one is G1 ring sum G2. This is actually the union of these two graphs without this edge. Okay, so we're going to copy the whole G1 union G2. So we have 1, 2, 3, 4, and we have 5 here and 6. So we're going to start with E2. We're not going to draw E1. So G1 ring sum G2 means G1 union G2 without the common edge. No common edge or edges if we have more than one. E3, we have from 1 to 4. E4 is 1 to 3. E5 is 3 to 4. So that's it. This is our answer without E1. Okay, so it's like G1 union G2 without the intersection, without the edge or edges which are common to both. Now here we have G1. So don't look at G2, look at only G1. We have two graphs here, G1 and G2. But the question is G1 minus V4. So this is deleting point. So all the points connected to this, all the lines connected to this point will be removed as well. So we have V1 here. This is our V3. This is our V2 and V5. So we don't have V4 anymore. It's deleted. So we have E1 here. Our E2 is removed. This is our E3. Okay. We don't have E4, E2, and E5. So this is our answer. G1 minus V4. It's like killing someone, It's like killing someone. All the connections to that object or person will be disappearing as well. So 3 edges were removed because we don't have V4 anymore. Okay. Here, this is about removal of an edge or edges. Here we're going to remove 3 edges, G1 minus E5 minus E3 minus E4. So I'm going to put the answer here. First is to draw the points. We have V5 here, V3 and 4. This is our V5. 5 is not clear. Okay, so E1 is still there. E2. Okay. E3, E4, and E5 are not there. These are all deleted. So E5 is deleted, 4 and 3. So this is the answer. This is your homework, G2 minus E6. You have to delete only E6. Now, short circuiting, what we'll do is to combine or merge the vertices or the points without removing any connections. So we have to retain the connections. So how do we solve this? Here we have V1, V2, V3, and V4. And you're asked to short circuit V3 and V4. This is our V3 and this is our V4. So we can put it here and name it as W. But this actually contains 2 points. This is 3 and 4. And here is our V1. Let's change the color. This is our V1 here. You can see it. Okay, this is our V1, this is our V2, and here is our V5. So let's start with E1. E1 is from V1 to V3, but our V3 is here now. So this is our E1. Our E2 is from V1 to V4, but our V4 is here. So we have to draw a multiple edge. That's our E2. Our E3 is from V2 to V3. So it will be from V2 to W, because our 3 and 4 are here. And our E4 is V3 to V4. But V3 and V4 are together. So it will become a loop. Okay, that is our E4. And our E5 is from V2 to V4. So V2 to W. This is our E5. So this is our answer actually. We short-circuited V3 and V4. Still, we have 5 edges. As you can see, E1, E2. Then we have E3 here, E4, and E5. Okay, so this is how to short circuit. Here we're going to contract E3. When we contract, actually, we delete that edge and short circuit the vertices involved. Okay, so contracting actually is removing the edge, and then we short circuit the vertices involved. So our V1 and V2 will change, okay? But it depends where you're going to put it. See, the points involved are V2 and V3. You can put it here. Okay, this is V2 and V3. They'll be together now. We're going to short circuit these 2 points because these are the points used by E3. So basically we transferred our V2 here. Our V4 is here. And still we have our V5 here. So our E1 is from V1 to V3. Basically it's the same because our V2 and V3 are here. E2 is the same, V1 to V4. Our E3 is deleted, is removed, is contracted. Our E4 is V3 to V4. So it's the same. But our E5 will now change because E5 is from V2 to V4. Okay, and our V2 is here and V4 is there. So we have to draw a multiple edge. This is our E5. Okay, so this is the answer where E is contracted. It becomes like this. Right, so I hope this is clear. So that's it. We are done with the operations on graph theory. Thank you so much for watching this video. Until the next time, bye-bye.